I will explain to you the technique that we need to follow when drawing an organic molecule. Before we start drawing, you need to know that carbon atom makes 4 bonds. Those 4 bonds could be 4 simple or double and 2 simple bonds or triple bond and 1 simple bond. Always when you are reading the question and you want to draw the molecule, I suggest you start drawing it from this side. You read from the last. Like for example here, I'm reading ane. It means that the carbon chain contains all single bonds. And then hex. Hex means we have 6 carbons. And on the second carbon, we have a branch of 1 carbon. So let's start here. We're going to draw 6 carbons. As I said, on the second carbon, we have a methyl group. And that's it. These are the branches. After you put the structure, the skeleton of the compound, you need to complete the bonds with hydrogens. So as I mentioned, every carbon takes 4 bonds. So the rest is just filling the molecule with hydrogens. And this is the drawing of 2-methyl hexane. Now let's take another example. 2,3-dimethyl pentane. As I mentioned, you start from the last. That's an ane, meaning all the bonds in this compound are single. Then here's a pent. Pent means I have 5 carbon chains, where on the second and on the third carbon, you have methyl groups. Methyl is a branch and we have 2 of this branch. So let's start a 5 carbon chain. On the second and on the third, I have a branch of 1 carbon. 1 carbon, 1 carbon. Now we're done with the skeleton. We need to complete it with hydrogen bonds, with hydrogen atoms. And as I mentioned, every carbon can take up to 4 bonds. And now you fill the rest with hydrogens. And this is the drawing of 2,3-dimethyl pentane. Another example with the hydrocarbons, alkane. Here I have another pentane, but it's a cyclic pentane. A cyclic means you need to draw a closed ring. A ring of 5. That's a ring of 5. Now, this is the cyclopentane. This cyclopentane, on the second carbon, you have a methyl group, and on the first carbon, you have 2 ethyl groups. Now, the second carbon and the first carbon could be anywhere. So let's say I want to start counting from here. I want to number this as the first carbon and here as the second carbon. So on the second carbon, I have 1 carbon branch. That's a 1C branch. And on the first carbon, I have 2 branches. When you see 2 numbers, means 2 branches. 1 number, 1 branch. So I have 2 branches, each of them made up of 2 carbons. So that's the first branch. That's the first branch. And that's the second branch. Each branch is made up of 2 carbons. And now we're done. We complete the bonds with hydrogens. This carbon is taking 1, 2, 3, 4. 1, 2, 3, and 4. And that's it. This is the molecule of 1,1-diethyl 2-methyl cyclopentane. Now let's take other examples other than alkane. So for example, if I have an alkene or I have an alkyne like octene or hexyne, octene is a double bond. Now the number that you see here is telling you that this double bond is on the first carbon. Whereas here, the triple bond, the number here is telling you that this triple bond is on the third. Now oct means 8 carbon and hex means 6. So let me start drawing the first one, oct. So now I'm gonna put 8 carbons. Those are 8 carbons. On the first one, I have a double bond. I can consider this to be my first or this to be my first. Whatever you want. Now, on the second and on the fourth carbon, I have branches. Each branch is made up of 1 carbon. Methyl is a 1 carbon. So 1 carbon, 1 carbon. That's it. And now we complete the rest with hydrogen atoms. One, 2, 3, and 4. So this carbon will only take 2 hydrogens, whereas this carbon will take nothing. 1, 2, 3, 4. It's already saturated with bonds. So here, this one, hydrogens. And that's it. Now, another example, the 2,2-dimethyl 3-hexyne. So as I mentioned, you have 6 carbons. 1, 2, 3, 4, 5, 6. Where on the third carbon, you can place the triple bond. 1, 2, 3. Here's the triple bond. You'll put it after, because if you put the triple bond here, that means it's on the second. So here's the third carbon having a triple bond. Now, let's see what else we have in this compound. We have 2 branches, both of them on the second carbon. Each of them has a 1 carbon branch, methyl. Now we're done. The rest is to put the hydrogen atoms. Remember, every carbon can take 4 bonds. Now this one over here doesn't need any hydrogen because it has 1, 2, 3, 4. No more hydrogens on it. Also this one, 1, 2, 3, 4. I cannot add hydrogens on those 2 carbons. Whereas this one, 1, 2, 3, 4. And here, 3 more hydrogens. Now, I want to show you how to draw other compounds other than hydrocarbons, like alcohols or carboxylic acid, aldehydes, ketones. The most important thing in this part is that you have to know the formula of the functional group. You need to know the formula of the functional group. If you are not very familiar with the functional group, you cannot draw the compound. So you need to know the functional group and the naming. So here, anal. Anal means I have an aldehyde. And as mentioned in class, an aldehyde functional group is COH. So you take this functional group and you put the rest. What does it say here? It says meth. Meth means 1 carbon. So that's it. This is the 1 carbon. I'm done. All I need to do is complete with hydrogens. This carbon is taking 1, 2, 3, 4 bonds. Let's take another example. Anon. Anon means a ketone. And the ketone means I have a C double bond O between other carbons. So I have a carbon from here and carbons from here. So now I'm gonna put the functional group and then complete to finish the drawing. That's a C double bond O. Now it's a prop, and it says that this anion is on the second carbon. So here's the second carbon. This has to be the second. And the whole chain is made up of 3 carbons. So I have 1, 2, and that's the third. And I'm done. No branches in this one. Now I put the hydrogens. Now, butanon, anon, again, it's a ketone. A ketone means I have a C double bond O within the chain. So here's a C double bond O. Now this chain is made up of 4 carbons and this on is on the second. So that's my second carbon. It means there's 1 before, third, fourth, 2 butanone. No branches on this one. So now I put the hydrogens. Just pay attention that this carbon doesn't take any more hydrogens because it already has. It has 1, 2, 3, 4 bonds. So no more hydrogens on it. Now finally, the last example in this video tutorial, propyl ethanoate. When I read YL and anoate, it means I have an ester. And the functional group of an ester is C double bond O and O. It continues from here with other carbons, and it continues from here with carbons if necessary. Now the propyl is always the branch part coming after the O. So here's the C double bond O and O. Now from this side I have a prop, 3 carbons, 1, 2, 3. On the other side, the part that takes anoate comes here. It's 2 carbon. It means first, and that's the first and that's the second. And we're done. We didn't study branches on the propyl, on the esters. Yani no branches here or there. Okay, now I'm done with the skeleton structure. Now I have to fill it with hydrogens. And we are done.